Single soft, hard isolated, multi-tenant, single tenancy, hard multi-tenancy softness. This is what this means.
So what other controls would you have in a single tenant?
Jay! You dug a hole.
Yeah, exactly.
Jay,
Jay, coming back to it.
Hello, welcome to Cloud Unplugged. This is season 2, episode 14. I'm Jon Shanks.
And I'm Jay Keshur.
And as promised, we are going to take a little bit more of a deep dive. We don't have endless amounts of dives. That's why I've caveated with a little bit,
Super
obviously
deep.
just to set
Super
expectations around security decisions when you're going single and multi-tenancy on Kubernetes, and how and why you would make those decisions, what you make them on. So I guess before we were saying if you were being fully secure and there wasn't any other issues, you'd obviously go for full isolation. So if
you're
there was no other
optimizing for
constraints,
security,
exactly.
exactly.
If there's no other constraints that you had to worry about, cost wasn't a problem. There was magic tools that made it really easy and simple. You didn't have to worry about anything, and everything scaled and did it all for you, and all the magic was there. Then you would just naturally say, well, actually isolate all the workloads if also somehow the other issues were solved, like networking and how they're going to communicate with each other, these apps and all this other stuff. So if they aren't constraints, then from a pure security perspective, isolating the workloads is going to be better from a security posture perspective than sharing things, applications and workloads, sharing infrastructure.
Yeah.
Do you agree with that? Just before I say,
Yeah, that makes sense to me.
Yeah.
So isolating the workloads, well, isolating the teams, I guess, i.e. isolating the tenants from each other, because you could go super secure and isolate even that tenant's workloads. So take it down a little bit deeper.
Every single workload is isolated, even.
I mean, that's literally. I mean, the worst
mega
cost.
Well, I'm saying it's not a
efficiency,
problem,
right? It's not a problem.
No cost
The
issues.
worst management overhead or whatever, but
Not problems.
but
Not loads of problems.
if you're like, oh, I've got this thing, and I don't want any potential threat at all on this other thing that I'm running. Two different, things of data classifications and all this kind of stuff. Two different user groups accessing it. You just don't want to expose either in any way. Then you might even isolate those, right?
Yeah,
completely different clusters.
This is a fictitious world we're living in right now.
All of the monies.
So if all the things weren't issues or magically, then that would be the ultimate goal for like security. Was like it's full isolation. No workloads are sharing even the VM or anything, right? So you could go like full blown, everything is fully isolated. But obviously that isn't the world we live in, so there is still an element of sharing.
So much magic in this fictitious world.
So I guess then you have to think about security at that point, as in you've got to wind back up. And we're talking about things do share, because we do know there are costs and
management,
performance,
reliability, resilience, etc.
Exactly, all those are factors, and because of those factors, they now start to weigh in, because obviously doing it the way we suggested would be an insane amount of engineering to kind of go and work out how you're going to do it, and the cost of it if you're in cloud would be high anyway. So the probability of anybody doing it is slim. So why not share?
So all right, so away from this weird fictitious world, what's more of a kind of common pattern if you were you've got a single cluster for a tenant, what types of things or aspects of security would you want to kind of mitigate, just to kind of conform to best practice, just so we're grounding in something, I guess.
All right, so if you are sharing, you're saying, or even if you're single tenant,
you're not sharing.
So I'm not sharing; it's just my own cluster.
Yeah, just your own cluster, but just sort of baselining, I guess, what level of security you'd have even if you weren't sharing, and then we can build on the level of security or the risk that you might want to mitigate if you were sharing.
Yeah.
Do you see? So we can contrast the difference.
Questions would be. Are there going to be any secrets involved in what's going to be hosted?
Of course, yeah. There's always
there is, of
secrets,
course.
right?
So there's always going to be secrets. So
think about it. I mean, if you we're talking real general sense, right? So we're just talking kind of normal application workloads, those workloads
so
might
you
have
assume-
access to databases and things like that.
So it's not just a really simple basic app.
It's not. These basic
these
apps. This is a little bit more complicated.
All right, so it's more complex. And it's going to have some secrets in there,
Yeah.
and either way, I suppose you're going to have RBAC on the
why-
cluster itself, as in like
Do you?
access to the API. You need to obviously talk to the API with some authentication.
Why does it have to be role based?
We need to auth, and then that auth needs some access to something.
Yeah, but
Otherwise, there is no auth. Basically, there's no RBAC at all. It's just flat, which obviously you wouldn't want to have, even if it was owned by you.
yeah, I mean, there's different kind of access methods.
That's what I'm saying. RBAC, role-based access.
Role based, yeah, but it doesn't have to be role based. It could just be kind of ABAC, which is not that, right?
But you want to be specific, because I'm presuming if we've just gone from a
you're
really simple app,
authenticated, but you
and
don't.
if it can't be a simple app, because what you just said is like can't be a simple app, then it can't be a simple team either. So if
it's only one team is the point, so you may not need that.
Well, I would, because it's going to be. I thought before we're talking about there's other things in this cluster, presumably, right? Like ingress and cert manager and those things. So you're saying they don't need RBAC?
They do, yeah.
All right, so then we need RBAC.
So I get
because those things have to get into the cluster somehow.
So now we're talking about a platform team that's created them. Okay, so there's RBAC.
Yeah, that's what we started with in the premise.
Sorry, my fault. So there's you would need RBAC because you have a platform team.
So I just
that's
assumed
created
context
this.
here from as
Sorry,
if everyone listens to every single episode.
Yeah, exactly.
Well, we decided, just to recap, decisions were before that it's a platform team managed cluster that's going to be provided to bring one-to-many different services that enhance the experience for developers: certificate management, auto-scaling, ingress, DNS, all those types of things. There's way more obviously than those things we've listed. And it wasn't just bare bones Kubernetes only, just to host some apps. It was going to get enhanced. So because of that, I mean, even thinking about security, I don't think a security team would be best pleased that literally anyone that accesses that cluster or supports anything in that cluster has access to anything generically.
Yeah,
it's not a great security model.
Probably isn't.
No.
So I guess also because that platform team is managing that, they don't want to keep making changes to stuff that people have broken because they have access. So yeah, RBAC is a good place to start.
Yeah.
What's next?
Well, if we're talking about secrets, and there's going to be secrets, which obviously there now has to be anyway. I've caveated even for myself because things are running in there, and they're probably going to need secrets. Then the encryption of those secrets. If it's in the cloud, then you can probably use KMS or something to encrypt those secrets behind the scenes. The actual operating system itself, obviously you might want to start there. The slimmer the better, the less things on it the better, the more read-only the root file system is, obviously that's good. You can create a separate partition for say the Docker containers that can't be read-only because they've got to be pulled down and write. So
let's just go back a couple of steps. So secrets and encryption. So now, obviously, we're talking about the cloud-provided Kubernetes clusters.
Yeah.
Kubernetes
it doesn't have to be,
service.
but I'm just saying, whatever it is, you want to encrypt. Yeah. The back end is going to be etc.
Yes.
That's storing in data in there. You want to make sure that's encrypted at rest.
Cool.
But then also there is secrets object in there. And you probably want to make sure that's encrypted with something uniquely.
Isn't that just part of the data store that's encrypted?
You can use KMS to actually encrypt the secrets themselves.
Yeah, there is a concept in Kubernetes, isn't there? Of like they think about secrets in a different way and slightly more, I guess, controls around it.
Because
and it has almost a different partition in it.
Well, exactly, because you could, in theory, have. This is all quite a little bit theoretical, but somebody, might be allowed to look at all data from etc. Because they're responsible operationally for it. That doesn't mean projects are comfortable with them also being able to see the secrets or whatever. I guess it just depends on roles and responsibilities. So you might want to make sure that secrets that are quite sensitive to that project line might want encryption at the secret level, obviously. So you do want to make sure that at the rest level,
because accessing those secrets would be managed anyway through RBAC.
Yeah.
So it's just...
Well, now I'm thinking about you could export the data from etc.d, is what I'm talking
Right,
about.
okay, cool, yes.
In which case then it's just all flat, right?
Cool.
Because it's now not encrypted, which then means you get secrets too.
Mm-hmm.
So like, I'm not comfortable with that if you do export the data from etc.d.
Yes.
That somebody also then could just see the secrets because they're not encrypted, so then you could encrypt the secrets with something else, so that even if they exported it, they wouldn't be able to decrypt the secrets. They need a key.
Cool.
Secrecy, that's what I'm talking about.
Great. So it's encrypted in the database, and then it's encrypted at rest.
Yeah. Would you do that?
Yeah, absolutely. Yeah. Makes sense.
Yeah. And then obviously the operating system. So I don't know what you've seen, different operating systems for obviously the root file system being encrypted. There's obviously been a change. There's loads of OSs nowadays.
Yeah, so obviously the kind of cloud provided managed Kubernetes services, the control plane is always Linux for the most part, right? And then you have a bunch of node groups, node pools or whatever to manage. You can have those on Windows, you can have them on Linux, you can have them on many different flavors of Linux. Let's just assume that it's a flavor of Linux, and then you obviously got file shares to manage within that, and where those Docker containers are running from. Obviously, that's some of your business logic that you're running within those containers, and having them on sort of unencrypted drives isn't great, because it's cloud, it's infrastructure, right? So it's virtualized, which means that at any point it could be scheduled into someone else's account or whatever, and there is a process of like potentially gaining access to things that have been running on that before. So you obviously need to kind of protect yourself from those types of measures too. So having kind of encrypted volumes, having containers that are running from encrypted volumes makes sense.
Yeah, and then preventing installation on the root file system obviously is good too. So if you can make that read only and then have a separate file system for where the Docker images are going to be coming from, and that can be right. But then you can put the controls then around the containers themselves and what they have access to or don't have access to. But then that stops people also being able to write to the main root file system and overwrite certain things on there, pretending that they are the real processes.
Yeah. So real immutability, really.
Yeah, pure immutability. Obviously, some people also try and encrypt the root file system, but then obviously it's a bit more complicated at that point on all the key management and decryption. So you can just divide it up.
Yeah, I mean, I'm not sure why you would ever really need to if you're using...
if you do it that way, you kind of don't, because you can't do anything anyway. But if certain operating systems, it's not possible.
Maybe if you're baking your own image.
Baking your own image,
rather than just using, something off the shelf.
Yeah. But yeah, so that's normally you're starting at that level because you've got to provide these things.
Of course.
Obviously, networking and all those things will be kind of important, but you're going to be inside of Kubernetes. Your topology of what you're thinking about up front, around is the infrastructure just all shared equally?
But we're talking about the single shared cluster.
Single shared?
Yeah.
But if I'm saying, even if it's single shared within my project, even the applications, are they all equal in risk?
Oh, I see. Okay.
Right?
So,
am I comfortable with all this app just being equal in security, even though I'm not sharing it with anybody?
Yeah.
Or are there certain apps actually I'm a little bit worried about? I don't know why you would be, but you might have a real legitimate need.
So this is, I guess, the concept of soft and hard multi-tenancy. So I know.
What's the difference between soft and hard multi-tenancy?
Yeah, another thing. So hard multi-tenancy, hard tenancy, I think, is when you're in single clusters, i.e. you've got hard separation between the kind of control plane and everything else. And then soft multi-tenancy is where you've got you're sharing, say, the control plane, but not the worker nodes. So you can't have multiple...
is that right? It sounds like it should be the way around, like soft multi-tenancy. If it's just multi-tenancy or tenancy, because obviously to have a tenant, would presumably mean it's been
or
shared.
soft segregation, hard segregation.
Yeah, 'cause it feels like soft would be that it's just the control plane, but then it's flat and the infrastructure isn't. And hard would be the infrastructure, the control plane is shared, but the infrastructure isn't, as in it's hardened a little bit.
So the hard is basically, it's out. It's like the control plane and the worker nodes aren't shared.
But then it's not shared. Oh, it's single tenancy then.
There is
no tenant.
The platform, I guess, is the concept of tenant. Is that right?
It sounds odd. Where is a tenant coming from? You're just a tenant of one.
Soft tenancy. I need to Google this because there is a concept of soft and hard, and I can't remember.
Is it
exactly.
in relation to multi-tenancy within itself, as in you can be really strict within multi-tenancy?
Exactly.
Well, you can be as strict as you can with taints tolerations, which we're not going to get, which we should get onto at some point, but where it's then the infrastructure nodes aren't shared from an application perspective. Yes. I don't know. I'm just guessing from what you've said, and I've heard the term, but I've never really pay attention. It just sounds like that's what it might mean.
So hard multi-tenancy is obviously strong isolation, which is exactly
like node groups,
what we talked about, right? With not sharing the cluster and not sharing the shared services. So it's hard isolation.
It's just called shared hard isolation.
Yeah, so it's called isolation rather than tenancy.
Yeah, I was going to say.
And then soft is when there is a little bit of softness to that, and so you'll share the cluster API potentially, but not the.
That makes it multi-tenant.
It's up to you what your level of softness is. So whether you want to share the API and not the node pools.
So it's soft isolation, hard isolation.
Exactly that. Exactly,
and then
your versions of softness change.
Very soft.
I know exactly.
Medium soft.
This is getting to a weird place for you.
Yes,
what? So basically, super hard tenant isolation is separate clusters, complete separate clusters, single use
single
clusters.
Tenant then, basically.
Exactly, single tenant, and then there's ways to have soft isolation in a multi-tenant cluster, which is where you would have things like isolated worker nodes.
Yeah, but there isn't much else you can really do, because obviously the control plane is the control plane. The API is still the API. RBAC's still RBAC if you're putting it on.
You could have different shared services for those worker nodes.
Yeah, but that's nothing to do with Kubernetes specifically.
Yeah, no, but in this world of isolation that we're talking about.
I suppose from more generic platform things,
exactly.
But they might not even run in Kubernetes, those services.
How so?
As in, they could just be services that are ancillary.
I meant like ingress. You could have an ingress.
So in cluster services,
in cluster,
not just like
add-ons.
GitLab or some other services.
Even your in cluster services might be segregated in this soft tenant world.
Each project has its own ingress. Each project has its own thing. I see.
Yeah. So the only thing
extreme.
I guess I suppose there is. Yeah. That is an option. Obviously, Kubernetes is just a bunch of options in the end, but probably isn't something that you'd likely do, because now there's not much benefit to be gained when you are not running that API, the Kubernetes API and the control plane, because you could just get cloud providers to do it for you at a very small cost, in fact free sometimes.
Yeah.
So soft isolation tends to happen less so in that world, and so the different, I guess, ways of then isolating apart from just say the worker nodes is obviously the clusters, and in this world where you just have the single
so many
cluster.
People have just probably got so confused.
I know, exactly. I'm just going off a bit of a tangent, but in the single
the single
cluster
soft,
world,
hard isolated multi-tenant, single tenancy, hard multi-tenancy softness.
Words.
This is what this means.
So what other controls would you have in a single tenant?
Jay, you dug a hole.
Yeah,
Jay,
exactly.
Jay,
Jay, coming back to it.
I guess if we rewind back, because I guess we're inferring a huge amount of knowledge to a degree. So like anything, you're going to have an operating system or an AMI image or some image inside the cloud vendor. They have ones that are designed for running containers, operating systems that are specific just for running containers, not just like generic operating systems. That's obviously better because the principle is everything's going to be a container.
Yeah.
And obviously there's security groups and all these other things that isolate containers. So already from a kernel's perspective, you've got C groups and all the other things that are going to isolate, which is what it's about. And you get in the, I guess, what they kind of deem software virtualization, I guess. So isolated at the operating system level. And that's basically what gets provisioned, and then there'll be a kubelet on there that is obviously talking back to the control plane, and then that's sending information about itself to be like, hey, this is my CPU memory, and this is who I am, this is what's running, etc. And then that's going to talk to the runtime that's then going to obviously run containers on it. But then the control plane that you're speaking to in Kubernetes, what we're saying is, well, if you've made those decisions, then obviously there's be Kubernetes objects. That'll be, here's my app, this is what I want to deploy. Here's a container, this might need a secret. What we're then saying is, there's a secret object now. I'm a bit worried about that because that's going in some data. What about if somebody exported that data?
Yeah.
Could they export the secrets as well? No, because we need to encrypt that too.
Yeah.
So now you've kind of got some levels of security from when people actually are putting objects, Kubernetes objects, and telling the API what they want. It's going to go off and reconcile and make those things happen that you've asked for, if it can. But then the workloads underneath, you've already made decisions on even what the operating system is under that, that's then isolated, and even the partitioning on it, and then the encryption of that partition even, just in case. That is ancillary to Kubernetes, but isn't Kubernetes itself.
Yeah, exactly.
Right?
So I guess you're just talking about the actual, not within the API at all, really. It's just the actual node itself, just and how the containers are running on those nodes. Yeah, exactly.
Elements, right? Nothing Kubernetes-centric at that point.
Yeah.
The only bit it is then obviously the kubelet that I mentioned and the control plane. But actually where those containers are going to run, you'd want to do that anyway, even if you weren't using Kubernetes, is what I'm saying. So they're just best practices from an OS perspective. And there's best practices from a Kubernetes perspective. There's best practices from the data store perspective of Kubernetes behind. So there's layers. And
then, all right, so let's jump into the Kubernetes layer now at that stage.
All right.
So you've done nodes, they're kind of hardened, running that sort of best practices, using best practices that you've just described. What's next? How would you isolate, or how would you achieve a kind of standard level of security at that level? Actually, another thing maybe at that node level is whether you're allowing some of those processes on those nodes to run in certain namespaces, or run or being able to be escalated into like privileged mode or whatever. So that's, I guess, that's kind of where Kubernetes touches the node.
Well, I guess there's
level controls.
A few things even before that. That's why it's a big topic. Is, do I want this endpoint for Kubernetes API to be public?
Yeah.
Does it need to be private?
Exactly right at the start.
What about access to it? What about the kubelet's also got a talk that I mentioned that's running on the VMs? Is that encrypted?
Yeah.
Does that have a certificate? As well for mutual TLS? Is it authenticating itself so something can't pretend to be that kubelet and start, getting access to data and information? So there's all these layers, because obviously it's an API. Kubernetes itself has to make sure that the things talking to it that it needs to function are also hardened.
Exactly.
And then also the decision of how private and how public do I want to operate? Am I just going to be like, I don't mind it's public because I'm going to rely on auth, and that auth might be OpenID, so I'm kind of relying on OpenID Connect, and that's fine, and my security posture is I'm okay with that because it's an endpoint that's encrypted and I trust single sign-on, and OpenID flows, and then my RBAC. Or that's still too risky, I still want all of that, plus put it on the VPN and don't make it public, or lock it down to only IPs that I know and then firewall it off, but it could still be public. So there's lots of choices even right at the beginning to be
Yes.
made before even you get to running workloads
When
on
you've
it.
got your control plane, Kubernetes.
Just at
exactly.
like installation stage.
Yeah.
Um,
And then I guess when you're getting a little bit closer to, understanding how to run workloads, what's next? How are you going to...
just so eager to get something.
Yeah,
running.
I know, exactly. I mean, I have this cluster, right? Give me
I mean,
give me
I've
access
just
to
validated
how do
whether I
I...
want to run anything on this cluster, Jay. It seems a bit gun-ho. Like, you don't seem to be, there's no RBAC on it, apparently. It's all
There's
flat.
RBAC. There is RBAC. Come on. It's and we realised it's a soft, no isolation. Exactly.
Keshur. So I do think though those decisions, even those early decisions, make it harder, because if it's private, then obviously the VPN is there, right? You need some form of VPN, otherwise how are you actually even accessing it?
Yeah.
So
well, not necessarily VPN. You could have a bastion. Or a jump box where that's
true.
somewhere, and exactly. So
you're
just moving the boundary.
Directly talk to it without. I mean, you could directly talk to it if you're on the network of it.
You're moving the boundary to something that else
it's
that
internal.
can talk to it. Yeah, exactly.
It's an internal boundary now.
Yeah.
So that can make it a little bit harder, obviously, to then do all the automation around everything. If you've then got to go off and deploy the things in after the cluster's built, like the ingress, like the certs, how is that thing? What is the thing that's talking to the API that's now on a private network, and does it have access to it?
Exactly.
So obviously from a Kubernetes perspective, that stuff isn't always there. All the things you might want won't be out of the box. Some things might be from the cloud vendor that you can choose from, and there'll be a bunch of other things that you're going to have to then put on even before anyone's deploying the app, Jay.
Even before, wow. Sounds like a lot of work. Right, so I still want to deploy my app, Jon. Right, so could you...
So anyway, 4 months later, when we've got through all of these decisions, what do you mean Jay got another job? Does he not work here anymore? Where's he working now?
Somewhere that
just
lets
that his cluster's ready?
Yeah. So. Someone that lets me use bloody Kubernetes. So... Right, what kind of controls are you gonna put in place so that the workloads can run in a secure way?
so I'm gonna do
some workloads.
I'm gonna do some security for the security thing you asked for.
Oh, thanks. Yeah, thanks. Cool.
And that's it. That's the end of the episode. So that's the things I'm gonna do, and then you'll be able to run your secure.
This is why Jon has paid the big bucks.
Yeah, exactly.
Security for security's sake.
Yeah, I'm gonna do the security things. Don't worry. They're all done. What is it you're asking for? So you want to...
So what is best practice around running workloads in a secure way that where Kubernetes configuration meets best practice for running processes on nodes?
So you're saying now from an infrastructure level, you want to isolate some apps to specific bits of infrastructure so they don't share fully the infra. Is that what you're saying?
Not necessarily fully the infrastructure, but so that they can't escalate out and break out of the app.
I see.
Break out of the container.
Well, there's a few things you could do, and some of them overlap. So you obviously solve the problem in different ways.
Yep.
But you can use PSS, which was originally PSP, pod security policies, pod security standards. Is it standards or system?
There's
security. I always forget
pod security admission, which is the first kind of layer of that, and then pod security.
The actual policy itself, which has now been diminished because they've moved a lot of it to be more driven by policy agents.
Yeah, exactly.
But that's what I'm saying. It's kind of evolved a little bit, where before you'd have a pod security policy, and that was some kind of generic elements that was kind of limited on scope of how much it would do anyway.
Yeah.
That's like, well, I don't really want people mounting in the host network. I say people, containers. I don't want containers.
Same.
There's just many people running. I don't want containers being able to be orchestrated to then mount in file system elements, specific things from other containers, etc. So you'd do isolation. Other things would be the actual process inside the container shouldn't be root. because then if it gets exploited, obviously then it's running as root. People can install things then on that container and do other stuff. So you can kind of start to enforce all these standards as policies to make sure those things. Read-only file system again. You might be like, actually, read-only root file system. Can't speak today.
And then moving across user groups or user namespaces in the Linux kernel. So being privileged or whatever. Then
there's set comp policies as well, which is the types
policies.
of system calls that could be made by that process that's running inside that container. So you could even be really, really locked down. You can use SE Linux.
You can drop capabilities.
You can drop capabilities,
so that you can never expose, the capabilities that container shouldn't be able to have, binding to certain networks under certain ranges or whatever.
There's a lot you can.
There's a lot, right?
And that's just quite low level to a point because you need to kind of understand what that would mean.
Well, you basically need to be a Linux admin. It's the same skills that you would have as a Linux administrator, really. Back in the day.
If you were aware of like system calls and things like that,
exactly.
if you were low level enough to understand like how processes work and user space and kernel space and all those things, then I suppose it infers quite a lot of knowledge around how to secure what's running on it. But if there were Windows containers, obviously different.
You've got very similar concepts nowadays, obviously, because Windows and they're sort of merging to a certain degree, aren't they?
It's definitely aligned more over the years, hasn't it?
Obviously different
but that's
ways.
not my speciality, Windows, so I can't really comment on the
nor mine, which is why I'm like just glossing over it really quickly.
Kind of the same nowadays, aren't they? Moving on. Not my real speciality, but so those would be the main things. What would you be doing? So say if a team was had some scenario where there was some front end services and back end services, and maybe like one of the back end services is PCIe right in nature, but it's single tenant anyway. Would you still want to architect differently, or would you treat it the same?
Potentially, I guess it. So I guess the front end, really, because you've already got an ingress layer, is you're keeping that separate, and so all traffic coming into your cluster might be on potentially a different node pool, and then everything else is exposed internally in the cluster anyway, right? Because you're not actually getting you're not binding certain pods directly to a load balancer. You're going through an internal service, i.e. a load balancer exposed through ingress.
But then
with
there will be a load
Nginx
balancer.
Exactly, and then you've got
another. If we're in cloud, then there'll be a cloud
load balancer to the ingress, which is the internal kind of load balancer inside the cluster.
Most of the time, not always, but Nginx.
Yeah, exactly.
Under the hood.
And then that is then kind of routing traffic to your pod through the service kind of definition of that pod. So it's kind of load balancing internally to your pod or pods. So at that stage, it's internal anyway. So I'm not sure you would necessarily need to kind of segregate that off to a certain space. But if you wanted to apply,
but say that this external facing thing that is then the ingress.
Yeah.
That ingress is living like on what VM, like where?
So that you'd probably have a separate node pool for where ingress is.
Okay, so you'd like thinking about carving it out, because otherwise if it was flat, then it could be on the same node.
Exactly, it would be on the same nodes, exactly that. So you'd have a different node pool for where the ingress is, and then, as I was saying, everything beyond that stage could be on one sort of larger back-end node pool. Even this front-end service is really just another layer of back end, really, because the front end is ingress.
But the load balancer's going to it.
Yeah.
So indirectly, but it's still going to it through HTTP protocol, even though there are stages of the routing.
Yeah.
But the full place will be, I guess we'll just be talking about risk profile. From an application perspective, it'd be like, right, there's some infrastructure we've done some of the hardening from an infrastructure level.
Mhm.
There's a bunch of other stuff we mentioned around hardening Kubernetes stuff and what you can and can't do. But now from an application level, the cluster's private, so I can't actually talk to the API of Kubernetes.
Yep.
But I can talk to a service that is hosted inside that private cluster.
Yes.
And that's public. Right?
That's public.
And
yeah.
that's now an Nginx, right, proxy.
Yep.
That's basically essentially then proxying traffic to a service endpoint, which is basically routing it then to an app.
Yeah, potentially an Nginx with a web application firewall
All right,
in
so
front of it.
WAF in front of it, yeah.
So I'd put a WAF in front of it, just to kind of mitigate, some of the kind of common risks like SQLs and injections and things like that. And then it would pass traffic down to your actual application. And you probably want that traffic to be protected. So even so your traffic to the ingress is going to be over HTTPS and encrypted, and then from the ingress to which is on one node to a pod on another node is going to have encrypted traffic towards from those two. So and then I guess you're talking about another backend service.
What's encrypting the traffic? What will be doing the traffic encryption? Because obviously the application, you're saying the application is designed for encryption, and they're going to have to do it at the app level. And
you could do it that way, but I guess to make developer experience really nice, you'd probably want to provide a bunch of like in-cluster services, and these are the things that we kind of talked about previously. So you can have something like Cert Manager running. So for the ingress, it gets a certificate from a free service like Let's Encrypt, and that's a free certificate that's lasts for 90 days and it renews itself and all that kind of stuff. And then maybe internally you have an internal certificate issuer, and the cert manager is automatically generating a cert using that issuer and giving it to the pod, mounting it as a secret for your application to then use, or even having a separate kind of sidecar alongside your application to terminate TLS. So there's lots of different patterns in Kubernetes, I guess. Lots of different add-ons you can use. You can use the Envoy kind of proxy. You can use Nginx, service meshes, lots of things.
And so whatever you use, I suppose what you're saying is you don't want it actually has to terminate. The TLS has to terminate at the container level, like the pod level,
exactly.
Really.
Yeah.
So that then obviously it's at a process level,
as close to the actual.
Not going over a network anymore when it's then
it.
talking to the service, but anything going over the network always needs to be encrypted. So otherwise, localhost obviously fine.
Yeah.
One thing to another, great.
Exactly.
That's all right.
Yeah.
But anything traversing actual network, then not okay to be unencrypted.
Anything traversing different nodes.
Yeah, anything over the actual network beyond local host.
I guess you've got a different concept of networks, right? Because you've obviously got the kind of Kubernetes layer network, and then the kind of host level.
But even then, that's pod to pod, right? So you'd want to make sure, because it could be on another node.
Yeah.
So I suppose any network that isn't localhost, just to be on the safe side, you just want to make sure that you don't know whether you're on the same node or not.
Exactly. Yeah.
But it's still going to route it as normal traffic. So
Yeah.
you want to make sure that's encrypted. And then what about if you need storage or something in my app?
Yep.
So you have the storage interface, and so that's going to be configured. God, we're going to make Kubernetes sound so complicated.
Yeah.
Please don't let any of this put you off using Kubernetes. But now the more I'm talking, you start to realise there's just quite a lot. But
there's a lot. Yeah,
there's
exactly.
a lot. So, and this is supposed to be security related. But yeah.
So we've talked about, I guess, the security.
We haven't talked about the runtimes.
We haven't. Yeah, exactly. So
but
we've talked about the security of where the file share that your images are running from. But there's obviously if your containers, once they're running, they actually need to mount some storage in that container. Then you probably want to encrypt that again using some sort of external key. In Amazon, you obviously have KMS to encrypt the EBSs, or
all the cloud
EFS or
vendors
whatever.
do.
Yeah, exactly.
They all have like a key vault
exactly.
element to it to be able to like
Yep.
obviously encrypt.
Yep.
Nowadays, so that's good.
So you've got that.
But there's also the standardizations that have happened over the years, as obviously vendors have, well, cloud's a vendor as well. So if you say vendors, I'm including cloud in it. But the more variety there became, the more standardization on interfaces. So then you had like, right, there's loads of storage that you could get. So we're going to have to call it the container storage interface called the CSI.
Which is also the container secret interface. So there's like a CSI driver and a CSI driver, like one's for storage, one's for secrets. Very fun.
And then there's obviously the runtime interfaces, which is all the different ways of running containers. And that's standardized over the years. And then there's the OCI, which is the Open Container Initiative, which is actually all these runtimes that you're all creating. We need to standardize on them because there's so many of them. We're going to standardize on that. That's when the OCI happens. There's just been loads of evolution around, not just Kubernetes specifically.
Just options around the space.
Just options around the space.
And then standards on those options.
Yeah. But really, to be honest, who cares? Just use... You know what I mean? Use runc, use containerd, like all this stuff's done. You just need to run a container from an application perspective. You know, you're going to need storage. We're saying encrypt it, right? So, and we're gonna need to run containers. Make sure the OS is.
Sounds like Jon doesn't want to talk about security anymore. He's just like, just doesn't matter. It's just too complicated.
Can we
just do it.
Not share someone's cluster who has just done this already? Is there a cluster out there that has done all this security that I could use? Like,
just have one of those, please. Thanks.
Yeah.
No, just your one.
That is why people do multi-tenancy. Because doing all those things repeatedly and going through all that.
Well,
is like
we haven't even again touched on like say some of the shared services, right? So let's say that ingress that you've set up, or Let's Encrypt or whatever, you then have a bunch of other things. You have kind of encryption modes, you have ciphers that you could be using.
Yeah, it does get
it's a lot.
Even the TLS element on the actual certs.
Yeah, just
getting those versions right.
Just
make sure you don't support the old versions. Like all the things of all the detail of all the stuff is that. Yeah, it's from a security perspective. There's a lot because there's a lot of components, and therefore all those things have to be done well from a security perspective. The more components, the more things there are to secure. Which is what makes it quite a headache. And
we again haven't talked about some of the risks that you might want to mitigate. So, kind of third-party supplier risk and where you're getting your containers from and things like that. Whether you're scanning your containers to make sure it doesn't have any vulnerabilities before you run it in your cluster with potentially your other workloads. What's the process they're going through? Are you standardizing on that? Who are you allowing to even deploy to your cluster? Is that a service that are you getting are you letting developers direct access your cluster, this cluster directly? Are you going through like a CI/CD system? Are you going through more of a kind of declarative approach with GitOps? What does that look like? So there's so many layers to.
But I suppose those layers.
security.
I mean, maybe it's more actually as you're like talking. Maybe it's more the platform responsibility. Because to be fair, those have always existed. Thinking about it, operating system security has always been a thing. Certificates have always been a thing. Patching, managing all that has always been a thing. Encrypting storage always been a thing. Encryption at rest always been a thing. Encryption in transit always been a thing. Like the principles have always existed. So it's always been hard. SE Linux been around ages. Making sure you audit, building SE Linux policies from the audit, all those things that you used to have to do anyway. All been things because processes are running on VMs. That has an operating system, and despite however it's got,
nothing's changed really.
Nothing's changed from that aspect.
Yeah,
just the only thing is you can share now the virtual machine, and there's more security boundaries within the Linux kernel that allows for that. It's kind of been the evolutionary bit, but then all the other things are still the same. But I think, and if you haven't come from that background and maybe you're learning for the first time,
overwhelming.
It might be overwhelming because they're all new concepts to you potentially, but actually they've been in the industry for a really long time. But just different a different shift of, it sounds like it's all Kubernetes, but actually in some ways, some of it kind of isn't.
Yeah, true. But I guess even in Kubernetes, like the cloud providers, if you're using a managed Kubernetes offering, then they're taking care of some of that complexity
some
away.
bits. You still have to tell it things.
Yeah, sure.
You want, because you then need to know those things that are
for sure
good things to pass in to the configuration of Kubernetes.
Yes.
That we spoke about. And maybe if you didn't know, out the box, the defaults might not be any of those things.
Yeah.
Because it wouldn't work. You go and get a private cluster, like, why can't I talk to the cluster?
How can I access this cluster? Yeah, exactly.
So, you might not realise. So out the box, the defaults are normally the reverse of those things, because it can't make assumptions. So I think that's when people might reuse a Terraform module or reuse something that's designed for consumption at the end, not designed for
the
hard
default
boundaries and security.
Exactly. Bad defaults.
Yeah, exactly. Well, bad from a security perspective, maybe, but not bad from a consumption one. Yeah, you're right. What about network policies?
Oh yeah, exactly. So segregating, which pods can talk to other pods. That's another kind of layer, I guess, of boundary control and security policy.
And then signing container images so that you know that they're coming from a place that you trust.
That's
GPG. Or even you can do OpenID.
Signed.
You can use the key of OpenID to sign. So you can actually keyless signing, can't you, as well?
Yep. We wrote a blog on that,
Oh, did you?
Yeah. We.
Oh, right.
Yeah.
Did we?
Yes.
Or did somebody?
Somebody at Appvia wrote a blog on it.
Oh, right, fair enough. But yeah, so there is a blog about that, that's true. But yeah, there's still all those things is you've not just encrypted, but you want to encrypt maybe the container image. Then you need to decrypt it with something, and that's going to give the trust. You can also use the hash, as well, which is actually each layer of the container image is hashed.
Yes.
Rather than like a
referring
version.
Referring to the actual hash, which is a thing that doesn't change, rather than the tag, which does change.
Exactly. So then it's like, actually, that's the hash that I'm expecting.
Yeah.
And then basically, I think it does the sum of all the layers.
Exactly.
And then sees, does the sum match?
Yep.
And then if it doesn't, then I know something's altered or that's not right from what I'm expecting.
Exactly.
So that's another thing you can do.
Injected something into a layer or whatever else.
Exactly, because the container is made up of many layers, and each layer has a hash. So there's loads and loads and loads and loads
of layers
of security that goes on.
Layers to images and layers to security.
And so when you are thinking about, probably what we have worked out is you'd probably do a lot of these things anyway, to a point.
If you have the background in Windows and Linux administration, then you're probably used to a lot of these best practices overall. But if you're not, then some of these concepts are going to be new to you.
But some of them don't matter whether you were single or multi, right? It's like, if I'm pulling a container down, how the hell do I know it was my container?
Yeah, exactly.
Right? If I'm not encrypted it, or I'm not validating any of it.
If I'm not checking that it's come from a reputable source.
Yeah, exactly. So I have no awareness of actually what's running in that container in the end.
Yes.
If I can't trust that it was mine, that's nothing to do with single or multi-tenancy.
No.
But obviously...
matters more if it's multi-tenancy.
Exactly, matters more, because if there's loads of things sharing that host,
it's going to affect everything.
It's going to affect everything rather than just the app line. So this is all like the decision process. But doing these things is obviously good, but the impact when it goes wrong changes.
If it's multi, exactly.
And I think that's the thing, isn't it?
Yeah.
But then doing it everywhere when it's singular, also harder, because how do I know that's done everywhere?
Yeah.
Repeatably, and how do I get visibility of all of that?
The management of it all. Yeah, exactly.
Then changes, and then there's the cost, and you're like, oh, this is quite a lot of money to do it this way. Yeah, but it's more secure.
Yeah.
You're like, yeah, but I've got to scale my team.
Yeah, cost in the implementation of it, the maintenance of it, the things that it might run in the clusters to support that way of working. Yeah, it's quite high.
It's very high. So if you were to go and get a security product and probably run it against a bunch of things, against your cloud account, against Kubernetes, against all stuff, you're probably going to get loads of problems.
Yeah.
Probably based on most of the things we've just mentioned, where it spit out loads 100%. Of these issues, and then you're going to have a big book of work anyway that someone's going to have to do. I mean,
exactly.
whether you like it or not, if you've tried to be secure,
Yeah.
if you haven't been secure, then you're not secure, isn't it? It's pretty simple.
Yeah.
And all these are the things you probably should be doing if you care about security.
100%.
But if no one knows, is there a problem? If a
Yes,
tree falls
yes.
and no one hears it, did the tree fall?
I'm pretty sure there's someone that knows. I'm pretty sure there's someone that's in there right now
Yeah.
with a lot of knowledge.
Cool.
So yeah, I guess we've talked about security quite a bit, and we haven't really given the other aspect of this, which is cost, because obviously, like we were saying earlier, everything's a bit of a trade-off. These are really the baseline minimum standards that you would, that we would potentially harden a node, a cluster, an organization's capability on. But we'll have to kind of talk about how to sort of have the same or similar sorts of patterns to managing cost at both the single and multi-tenanted level. And we'll do that in another episode.
Cool. All right. Are you going to do that? Yeah. Talk about
Sure.
costs. You love money.
Yeah, I love the costs.
Love the money. Yeah. Cool.
All right.